So let's say we have a concave spherical mirror and we have an object placed in front of the focal point. Are we going to get a real image or a virtual image? Well, to solve this problem, we need to make a ray diagram. When dealing with concave mirrors, the first light ray you want to draw will go from the top of the object straight to the mirror and then bounce through the focal point. Now the next light ray you want to draw is going to go through the focal point to the mirror, but since the object is in front of the focal point, you'll need to trace the light ray back through the focal point and then bounce it off the mirror. Now notice how the light rays are not converging at a point in front of the mirror. So to complete this ray diagram, you need to trace the reflected rays behind the mirror. Notice how when you trace the rays like this, there's a clear point of intersection, and that is where the image is going to form. But because this image formed behind the mirror, where the light rays are not actually converging there, we would say that this is not a real image, but rather a virtual.
What is specific heat capacity and why is it important? Let's have a look. A specific heat capacity is the property that describes how much energy is needed to change the temperature of a certain material. SI units for specific heat capacity is joules per kilogram per Kelvin, but in this table we're going to be using joules per gram per Kelvin. Let's have a look at two examples and compare them. Hydrogen has a specific heat capacity of 14.3, where the iron has a specific heat capacity of 0.412. That means hydrogen requires a lot more energy to heat up a 1 gram sample by 1 Kelvin. Interesting notes to take here is that metals tend to have low specific heat capacity. Have a look at aluminium, cadmium, iron, lead, steel. They all have low specific heat capacity, which means they require low energy to heat up a 1 gram sample by 1 Kelvin. Have a look at carbon dioxide. It has a low specific heat capacity, which contributes to its high global warming potential. Water, 4.18, one of the high specific heat capacities on this table. This means that it requires a lot of energy to heat up a 1 gram sample by 1 Kelvin. Let's talk about water in more detail. Have you ever been to the beach and noticed that when walking on the sand, it's a lot hotter than walking into the water? That's because sand has a lower specific heat capacity, making it easier to heat up. However, water has a high specific heat capacity, and this is a good thing. Water bodies, like our oceans, are less likely to experience extreme temperature changes. That means marine and aquatic organisms live in a narrow temperature band, keeping them happy and healthy. On average, the human body is made up of 70% water. And because of the high specific heat capacity of water, it allows our body temperature to regulate within a narrow band throughout the day, allowing proper function of metabolic processes and keeping us happy and healthy. In the calorimetry experiment, water is used as the medium to absorb the heat from the combusted fuel. Because of its high specific heat capacity, this means it's less likely to evaporate and remain unchanged in its mass throughout the investigation, making your results more valid. I hope that
Day 56 of a year of space facts. Mercury is the smallest planet by a good margin, but it's actually way more massive than you might think, and that is thanks to its incredibly large iron core. So the Earth's core is about 32% of its mass, but Mercury's is 70% of it.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
Is this what you'd expect? If you said yes, you've either seen this before or you're lying. As you might expect, the weight of the falling chain is heavier than the weight of the chain needed to get over the glass lip, which means it will continue emptying, but that doesn't explain why it goes so much higher. In addition, you can see that as more chain falls, the chain is pulled harder and therefore rises more. That's why it's even cooler to do this off of a parking garage. The height that the chain rises above the glass lip is dictated by the amount of chain that can fall. Of course, you gotta be careful not to tangle it or your performance will suffer.